Assalamualaikum and hi, my name is Aida Farisha binti Yaakob. My number matric is 33DTM20F1043. Next, for introduction, first our title is Potential of Sweet Potato Peel Powder that undergo different drying method as a food ingredient. I will talk about the background of study. The main sample in this study is sweet potato peel powder. As we know, sweet potatoes come in a variety of different colors. The variety of sweet potato colors is related to nutrient and sensory acceptance. The sweet potato used is an orange sweet potato. The reason why we choose orange sweet potato because referring to Nila et al. 2019 that orange sweet potato peel is rich in antioxidants, specific minerals and different vitamins that has the potential to deal with the problem of malnutrition faced by humans, especially children. Make sweet potato peel powder by drying the sweet potato peel in two different ways, which is drying oven and dehydrator with the use of different temperatures. Where to see the potential of the two methods that are more suitable for drying that can be used in industry. Temperatures in the oven drying are 40 degrees Celsius, 45 degrees Celsius and 50 degrees Celsius. Then for dehydrators, we use temperature of 40 degrees Celsius, 50 and 60 degrees Celsius. Like I said earlier, this orange sweet potato peel contain rich in antioxidants, specific minerals and different vitamins. So we want to do the analysis to study and want to know the total phenolic content and antioxidant in sweet potato peel powder that go through two different drying processes, which is oven drying and dehydrator.
Assalamualaikum, nama saya Abitul Faikah binti Aslan, nombor matrik 33DTM20F1015. I will explain about the problem statement for our project. The first one is food waste is increasing every year and every day, and sweet potato waste such as peels and root is also one of the factors contributing to the increasing in food waste. Second problem is the edible part from peel has its own nutritional value that should be uplifted as a food ingredient, which is by producing a product based on sweet potato peel that has been converted into powder. It can strengthen the nutrients contained in the food, especially the peel. This is because sweet potato peel contains an antioxidant and nutrients such as vitamin A. Therefore, by converting it into powder, sweet potato peel can be added to food ingredient.
Let's continue with research objectives. First, to produce sweet potato peel powder, two different drying methods are used, dehydrator and oven drying. Second, to determine total phenolic content and sweet potato peels that undergo a different drying process. And last, to determine the effect of two different drying methods on the antioxidant of sweet potato peel powder.
My name is Norin Azihah binti Syahal Rizal. My matric number is 33DTM20F1027. In this study, we focus on the peels part of sweet potato because it is usually considered as waste material. Later, waste is formed in large quantity during industrial processing and present a serious problem. Therefore, it needs to be managed and utilized. Besides, the alternative is to change potato peels to powder to diversify product in the food industry. It can help to reduce waste in Malaysia to some extent. This study was conducted to reveal the percent of antioxidant in sweet potato peels. Two analysis methods were carried out to find out the amount of total phenolic contents and also evaluate the antioxidant in the sweet potato peels after drying by using oven dryings and dehydrator at different temperature. Applying different temperature and different drying method is to find out which temperature is suitable for dryings to present the amount of antioxidant in a sweet potato peels. The growing knowledge about antioxidants that their presence in daily food can improve human health.
As for significance of study, use potato peel waste in the production of bakery products to reduce waste. Sweet potatoes are a popular vegetable, referring to FAO 2016. In 2012, it was estimated that 70% contribute to the waste of sweet potatoes worldwide. Orange sweet potato peel can be used in making bakery products such as bread and sandwich tin to overcome the wastage experience. Orange sweet potato peel is a process into powder and mixed during the manufacture of bakery products. The sweet taste found in sweet potato peel can attract the consumer. Then, sweet potato peel powder contains antioxidants that are beneficial to human health. There are antioxidants in the sweet potato peel. Some research have made an analysis related to the antioxidants in the sweet potato peel and they found the peel has antioxidants. These antioxidants can help prevent human health problems. The antioxidants found in the sweet potato peel is a beta-carotene. The beta-carotene content is high because the color of the sweet potato used is orange. The high content of beta-carotene can improve vitamin A deficiency for those who lack vitamin A in the body.
According to Ruhi et al. 2000, protein content was found in sweet potato peel was 41.3%. And it also found that among of the nutrient in sweet potato peel is magnesium. Magnesium is good for human body because it can help in the digestion process, while according to another study, it says that sweet potato peel has a good nutritional value such as carbohydrate and phenolic, which provide various beneficial effects and impact on human health, such as being a main sources of energy and reducing diabetes. Next is total phenolic content analysis based on another journal. According to Matters 2017, the analysis was conducted to differentiate the total phenolic content between sweet potato peel and potato peel. The result for the research analysis for total phenolic content in the peel of sweet potato is higher than the peel of potato, while another study compared orange sweet potato peel with purple sweet potato peel. And the result for this analysis is TPC content in purple sweet potato is higher than orange. This is because purple sweet potato has a high anthocyanin. This has proven that sweet potato peel has a high amount of phenolic content and can be used as one of the ingredients of the product. Next is antioxidant analysis based on another journal. This study, Kessel and Zeveles 2002, says that antioxidant in sweet potato peel can achieve 3 times other than plant tissue because of the orange sweet potato contain a high beta-carotene. Another study found sweet potato peel has antioxidant which is a beta-carotene. This antioxidant can help prevent human health problems. The high content of beta-carotene can improve vitamin A deficiency for those who lack vitamin A in the body. 2 different drying methods are used, which is drying oven at different temperature, which is 40, 45 and 50 degrees Celsius, and for dehydrator at different temperature, which is 40, 50 and 60 degrees Celsius. Lastly, we do the analysis the total phenolic content to see if the sweet potato peel powder has antioxidant content, while for DPPH analysis is to see the antioxidant activity in the peel.
The extraction method is based on the journals with slight modification. In short, the sweet potato peels will be dried at using drying and dehydrated at 3 different temperatures. Sample of sweet potato peels without wind drying were also used to see the comparison between total phenolic content and activity of antioxidant. Extraction will be carried out after drying using a centrifuge and evaporate for 1 hour at a temperature of 16 degrees Celsius using a water bath. The sample will be stored in the freezer to optimize the extraction quality to obtain the high amount of total phenolic content and antioxidant activity, because it can also avoid reaction to other components. Analysis of total phenolic content and also DPPH will be carried out, and the result will be read using UV spectrophotometer. These 2 analyses will use different formula to get the total content of each analysis. All samples from different process will perform in triplicate, and data will evaluate and meet plus minus standard deviation. Statistically significant difference were conducted through analysis of variance ANOVA using SPSS.
Next, I will discuss about the total phenolic content overall result. The control sample show no significant difference compared to the temperature 40 degrees Celsius for drying oven sample and 40 degrees Celsius for dehydrated sample that had been subjected to drying. The control sample showed that the percentage of phenolic content in sweet potato peel was 6.48%. For oven drying, the results showed that as the temperature increased, the phenolic content also increased from 4.83% to 25.48% to 44.22%. For all these 3 temperatures shows a significant difference. For the dehydrator, like the oven drying, the results show that the phenolic content increased as the temperature increased. At a temperature of 40 degrees Celsius, that is 2.83% to 223.44% for 50 degrees Celsius, and increased to 228.89% for 60 degrees Celsius. For a temperature of 40 degrees Celsius, there is a significant difference with a temperature of 50 degrees Celsius. While for temperature of 50 degrees Celsius, there is no significant difference with a temperature of 60 degrees Celsius. The most ideal temperature for drying sweet potato peel is at 50 degrees Celsius using an oven drying. This is because at this temperature, it shows a significant difference with different temperature and methods. This shows that the rate of increase seems to depend on different temperature and method. Malki 2008 state that the cause of reduced phenolic content is possible due to heat processing, which result in significant loss of total phenolic content in sweet potato peel.
Results show the entire DPPH reading for oven drying, dehydrator and control sample. The control sample show a significant difference compared to all the samples that have been subject to drying. The control sample show the lowest DPPH radical removal percentage of 59.20%. The trends of temperature in oven drying increase, reading activities. DPPH decreased from 89.39%, then to oven drying temperature 45 degrees Celsius which 87.17%, and final the lowest oven drying temperature 15 degrees Celsius 72.89%. Oven temperature of 40 degrees Celsius which is at 89.39% does not show any significant decrease. Temperature 45 degrees Celsius for oven drying, there was a decrease in antioxidant activity but not significant, while temperature 50 degrees Celsius there was a significant decrease to 72.89% but has a significant difference between temperature of 40 and 15 degrees Celsius. The temperature trend on the drying dehydrator increased. The reading of activity DPPH decreased from 92.56, then to the dehydrator drying temperature of 45 degrees Celsius, which is 88.201, and finally the lowest dehydrator drying temperature of 50 degrees Celsius is 81.38. The temperature of the dehydrator increased from 40 degrees Celsius to 15, showing a non-significant decrease from 92.56% to 88.21%. The next drop at the temperature of 60 degrees Celsius also decreased, which is to 81.38%, but no significance compared to the dehydrated temperature of 50 degrees Celsius, while the dehydrated temperature of 40 degrees Celsius has a significant difference between 60 degrees Celsius. So the best is 40 degrees Celsius at low temperature antioxidant activity at 92.56%, but there is no significant difference with temperature of 50 degrees Celsius. So the temperature of the dehydrator is 40 degrees Celsius. The idea is used to dry using a dehydrator because antioxidant activity are high, but there is no significant difference with 50 degrees Celsius. The reason why DPPH activity is lower when the temperature is rise is reduction levels of polyphenolic compounds found in methanolic extraction obtained from oven and dehydrated dried sweet potato peels correlates well to antioxidant activities. An indication that the decrease in antioxidant activity results from the degradation of phenolic compound at high temperature due to chemical, enzymatic or thermal decomposition. At high temperature, bioactive compounds with antioxidant activity can react with other components of the plant's material, thereby preventing extraction. Moreover, in frost air drying oven, phytochemical compounds can be oxidized because plant's material has greater content with oxygen.
As a conclusion, the sweet potato peel has advantage and benefit that are good for humans. Among the benefits are phenolic content that are found in the peel. There are several researchers who have studied the nutritional content of sweet potato peel, which cause sweet potato peel to have received attention to be added to the daily diet, because it has a good content for the diet. It also contains phenolic and antioxidant content, and the analysis we conducted was to prove that the peel of sweet potato has a antioxidant and phenolic content. The suitable treatment is that method oven drying for drying the sweet potato peel. This treatment is suitable to use because the results show that this treatment has a higher phenolic and antioxidant content. The suggestion for further research can improve in terms of adding various drying methods to see which method is more suitable to use, because there may be a better method than the two methods that we use. And for the further study, can make a study of sweet potato parts other than the peel, such as the roots. Lastly, industry can use the oven drying method to dry the peel if the industry wants to use the potato peel powder as one of the ingredients in food product in the future.